I love poker. I love betting. I bet on anything I can find. Horse races, basketball games, bet hundreds on that. One day I went to Atlantic City, borrowed $2,000 from my friend, lost it all. I don't know how I'm gonna pay him back. My girlfriend, she's mad at me. My mom, she's worried about me. I tried to stop. I just can't help it. I relapse back into it. My friends are worried about me. They tell me I need to stop, but I mean, it's not like I'm addicted to drugs.
According to the conventional definition of addiction, Greg is exactly right. The term is usually defined in terms of the compulsion to use a specific chemical substance, such as heroin or cocaine. The term is also often used in a broader sense, though. People talk about being addicted to non-chemical habits which are hard to stop, even in the face of negative consequences.
It's not like I'm addicted to drugs.
So just how similar are chemical addictions and what we might term behavioral addiction? Scientific studies into the neurobiological roots of chemical addiction have revealed that the comparison might not be as far-fetched as it seems at first. Studies of drug addiction in both humans and rats have shown a central role for the dopamine reward pathway, which transfers messages from the ventral tegmental area to critical areas of the brain including prefrontal cortex, basal ganglia, and the nucleus accumbens. This pathway is naturally activated by rewards such as food, sex, and other satisfying activities. Its activation indicates an unexpectedly good reward, which drives associated learning and memory formation in the prefrontal cortex. Here, Dr. Roche of the University of Maryland talks about the pathway's natural activity.
The dopamine neuron will fire when an unexpected reward is delivered. Okay, so you're not expecting a reward is delivered, a dopamine neuron fires. Okay. But slowly over time, as that reward becomes expected, predict that reward, that cell stops firing.
Research has revealed that all chemically addictive drugs result in hyperactivation of the dopamine reward pathway in the brain during use. This hyperactivation creates a constant signal of unexpected reward, which drives changes in motivation and long-term associational memory in the prefrontal cortex. These changes are thought to underlie some of the most universal aspects of severe drug addiction: the compulsion to use drugs, even in the face of negative consequences, and the proclivity for relapse, even after years of abstinence. While drugs provide a powerful dopamine reward, behavioral habits can also provide consistent rewards, potentially leading to addiction. Gambling is one activity which is seen as highly similar to chemical addiction from a symptomatic standpoint. Problem gamblers exhibit many of the characteristics commonly seen in drug addiction: euphoric feelings, dosage tolerance, as seen in the need for increasingly high-stakes wagers, a disregard for negative consequences, relapses after many years of abstinence, and even mild withdrawal symptoms, such as headache and insomnia, which are seen in 50% of problem gamblers in treatment. Here, Dr. Roche explains how these behavioral similarities reflect similar underlying neurological patterns.
Definitely similarities. So all drugs of abuse causes dopamine release in the brain. So you have gambling, which increases dopamine, and you also have drugs of abuse that increases dopamine. The difference is that in one case you're taking cocaine, you're chemically inducing the increase in dopamine. But in the other case, it's just the natural reward of winning unexpectedly that would increase dopamine. So it's definitely the same pathway.
Neuroimaging studies of people gambling in a laboratory setting show a strong activation of the ventral striatum, a dopamine target, upon winning. Studies also show decreased dopamine activation compared to controls in both drug users and pathological gamblers. The addiction paradigm has already helped to find new treatments for pathological gamblers. Preliminary studies indicate that opiate blockers, which downregulate the dopamine reward pathway and are used to help treat drug and alcohol addiction, may also help problem gamblers get better. Overall, the idea that gambling represents a behavioral addiction is becoming widely accepted and will soon be codified in the DSM-5, the Bible of psychiatric disorders. The discovery of a common neurological basis for both gambling and chemical addiction raises as many questions as it answers. If addiction can exist without exogenous chemicals, what other problematic habits might we recast as addiction?